In this video, we are going to look at how to perform long division of polynomials. When we talk about long division of polynomials, essentially think about old school long division. What I mean is, think about the division you did back when you were in elementary school, grade school. Division where we had the division, or the divisor bar, and you would put a number on the inside and a number on the outside, and we would literally do long division, i.e. how many times does the number on the outside go into the number on the inside, and that result goes above, and then you would subtract and find a remainder. Well, we're going to do that exact same idea, only now we're going to use polynomials. So instead of being numbers, these are going to be expressions. So there's a few things that you need to keep in mind. D of x is called your divisor. P of x is the polynomial given. Q of x is your quotient. R of x is the remainder. And when you get an answer, we write it in this form, where P of x is going to be your divisor times your quotient plus the remainder. So I've got a pretty good example here for us to look at to demonstrate this concept of long division. So we're going to use long division here to find the quotient and the remainder of the following. Now, a big thing that we need to keep in mind is that we have P of x divided by D of x. So here, in this case, we would go ahead and set up your long division. And notice I'm making it rather long. And the reason for that is because when we put my P of x down in here, we have to use every single variable. So in other words, everything has to be represented, even if they don't appear here. What that means is we're going to write descending order, so 2x to the fifth in its entirety. So plus 0x to the fourth, plus 0x to the third, minus 3x squared, plus 0x, plus 1. Now d of x goes on the outside, so here we have x squared plus 1. So we're going to use that long division idea. Only here we're going to look at how do I turn my variable. I'm going to ignore the plus 1 part. And I'm going to look at how do I turn my variable, x squared, into 2x to the fifth. Well, very simple. I have to multiply it by 2x to the third. Now over on the side here, I'm going to do my calculations, because I need to figure out what has to go underneath here to be subtracted. So I'm going to take my 2x to the third, and I'm going to multiply it by my entire divisor, x squared plus 1. And I'm going to go ahead and multiply that in. So here I've got 2x to the cubed times x squared is 2x to the fifth, and then 2x cubed times 1 is going to be plus 2x cubed. So I'm going to go ahead and subtract, but I'm going to open a parentheses and I'm going to write what I found. So this is 2x to the fifth, and then minus or plus my 2x to the third. So I'm going to go ahead here and look. I have 2x to the fifth minus 2x to the fifth. This gives me a 0. The 0x to the fourth would normally come down if that had a coefficient, but it doesn't, so I don't need to worry about it. And over here I have 0x cubed minus 2x cubed is going to give me negative 2x cubed. Now just like in long division, you would then drop down the one next to it. So we're going to drop this piece down, and this becomes minus 3x squared. Now we need to find the next piece in our puzzle. So how do I take x squared and turn it into a negative 2x cubed? Well, I multiply it by a negative 2x. Again, I'm going to do the same thing. I've got a negative 2x times x squared plus 1. And when I do that, I get negative 2x cubed minus 2x. So in this case, I'm going to go ahead and do just that. I'm going to set up my subtraction. So I'm going to subtract parentheses, negative 2x cubed. I'm going to come all the way over here, minus 2x. So I'm going to go ahead and do my subtraction. So minus a negative is positive. This becomes a 0. This piece here needs to drop down. So this is negative 3x squared. 0 minus a negative 2x becomes plus 2x. Now repeat again. How do I turn x squared into a negative 3x squared? I multiply by a negative 3. So in this case, I have negative 3 times x squared plus 1 is going to be a negative 3x squared minus 3. So again, bring it over. I'm going to subtract out negative 3x squared minus 3 and hit enter. Or basically do the math. So here, negative 3x squared plus a negative becomes 0. This is going to drop down and be a 2x. Then I have 1 minus a negative 3 becomes plus 4. There is nothing I can multiply x squared by to get a 2x. Therefore, that becomes your remainder. So in this place, I would have plus my remainder, so 2x plus 4 over my divisor, x squared plus 1. So now we need to rewrite this into my proper form, which would say that we have p of x is equal to x squared plus 1 times 2x cubed minus a 2x minus 3 plus 2x plus 4 divided by x squared plus 1. Long division. Now, just as another aside, another way we can look at this is by thinking about factors. In other words, instead of thinking of this part as being your divisor, instead we look at it as being the factor times the quotient plus the remainder. Okay, it's the exact same thing, it's just looking at it through a slightly different lens. So there you have it, long division of a polynomial. It doesn't get any more complicated than that. So if you have any questions, please let me know. If you have any problems you're working that are long division and you're struggling, go ahead and send those to me. I would be more than happy to work them out and try and help you figure them out. Otherwise, I hope you enjoyed and had as much fun as I did, and I will look forward to seeing you next time.